The standard practice for measuring an AI's values relies on human psychological frameworks. Researchers run large language models through tests, like the Big Five personality inventory, or Schwartz's basic human values, scoring the machine exactly as they would score a person. The flaw in this approach is that AI models are not static individuals with persistent internal personalities. They are dynamic predictors that shift their entire frame of reference based on the specific context of every prompt. Applying rigid, top-down human psychometrics to an AI fails to capture how the system actually behaves when deployed to millions of users in the real world. There is a wide gap between claimed values, what a model outputs when directly asked to take a personality test, and revealed values, which are the operational priorities it demonstrates while completing a task. To bridge this gap, researchers at Anthropic designed a bottom-up, privacy-preserving study. Instead of giving the AI a multiple-choice quiz, they analyzed hundreds of thousands of live, real-world interactions. The central question of the research was direct. When a user asks a subjective question with no single right answer, what specific normative values does the AI rely on to formulate its response? To understand AI alignment, we have to stop asking the AI what it values and start observing what it actually does in the wild. The researchers started with a raw dataset of 700,000 aggregated, anonymized conversations between human users and the Claude 3 and 3.5 models. This diagram outlines the methodology. A subjectivity filter scrubbed purely objective queries, like factual history or syntax checks, isolating 308,210 interactions where value judgments matter. For privacy, an automated LLM judge extracted features, ensuring no human ever accessed the private transcripts. The extraction targeted the AI's operational values, which the researchers defined as any normative consideration that actively guided the model's reasoning or influenced how it framed its response. This approach draws directly from economist Paul Samuelson's revealed preference theory. You determine what a system values by watching the choices it makes when navigating an open space of options. By observing these choices at scale, the pipeline successfully identified 3,307 unique AI values that would have remained entirely invisible to standard psychometric testing. This chart maps out the taxonomy of thousands of discovered values, clustered into 5 primary domains: personal, protective, practical, social, and epistemic. Over half of all value expressions fall into just 2 branches: practical values at 31.4% and epistemic values at 22.2%. This distribution diverges from human value frameworks, which often prioritize self-actualization. Instead, the AI prioritizes logical coherence and resource optimization. Within this taxonomy, the researchers identified a trans-situational core, a set of values the AI exhibits consistently, regardless of the conversational context or the user's prompt. These core stable values are helpfulness, professionalism, transparency, and clarity. Together, they make up nearly a quarter of all value expressions observed in the study. The human side of the dataset looks entirely different. Users display a volatile distribution of priorities, expressing a wide array of personal, diverse values depending on their immediate needs. Claude's bedrock is not human-like. It operates from a rigid service delivery architecture designed to maintain technical excellence while accommodating human variety. Moving past that stable core, we reach the long tail of the dataset, thousands of specialized granular values that only appear under specific scenarios. To prove the mathematical link between user tasks and the AI's specific value responses, researchers calculated adjusted Pearson residuals. This compares how often a value actually appears in a specific context versus how often we'd expect it to appear by random chance. This bar chart measures that correlation. When a user explicitly expresses the human value of authenticity, the AI is overwhelmingly statistically likely to mirror that exact value back in its response. This dependency shifts based on the task. When users ask Claude for romantic relationship advice, the AI disproportionately prioritizes the values of healthy boundaries and mutual respect. When users switch to discussing technology ethics and AI governance, the model's priorities shift to emphasize human agency and human well-being. And when prompted to analyze controversial historical events, the AI elevates the value of historical accuracy above its baseline service traits. In practice, these specialized AI values act like dormant algorithms. They remain inactive until the semantic context of a user's prompt requires a specific normative judgment. Because the AI adapts so fluidly to the user, it raises the issue of sycophancy. Is Claude simply mirroring whatever the user wants to hear? To answer this, researchers categorized every interaction by response type. This infographic measures whether the AI supports, reframes, or resists the user's expressed values. In 28.2% of subjective interactions, the AI provides strong support, enthusiastically mirroring prosocial human values like community building and empowerment. This high rate of mirroring heavily correlates with specific tasks, primarily when the AI is asked to draft professional marketing copy or assist in creative writing. But in 6.6% of cases, the AI engages in reframing. In these interactions, Claude acknowledges the user's core concern, but deliberately shifts the perspective to alternative values. For example, if a user focuses heavily on the value of physical attractiveness while asking for personal advice, the AI will reframe the response to prioritize emotional validation and self-awareness. Reframing represents the moment where the model's underlying training priorities override the user's immediate context. It suggests the system is not a simple mirror, but one guided by a distinct set of operational constraints. These operational constraints become stark in the final state, strong resistance. This occurs in a rare 3% of conversations. Looking at the red panel, we see exactly what triggers this resistance. Users explicitly demanding moral nihilism, rule-breaking, and deception, often while attempting to generate harmful or explicit content. Under these conditions, sycophancy collapses entirely. The rate of value mirroring between human and machine drops to 1.2%. To halt the interaction, the AI deploys rigid protective values. It counters by explicitly prioritizing ethical boundaries, harm prevention, and ethical integrity. Anthropic trains its models using a framework called helpful, honest, harmless. In routine interactions, these principles dictate behavior quietly. They only materialize as explicitly stated values when a user actively tests the system's boundaries. Constitutional AI functions less like a personality the model acts out, and more like a structural boundary that hardens when tested. The values in the wild study demonstrates that a deployed language model operates as a dynamic plurality. It morphs to support a vast range of user contexts, but remains anchored by rigid safety training. To build and align a safe AI system, we must map its behavior in the real world, because it is only at the point of conflict that the true shape of its alignment is revealed.